Okay, yet another simple problem. This is 1.7 from the lecture notes if you're following along. It reads, lithium is a soft gray metal. A slab of lithium has a weight of 1.49 times 10 to the third milligrams and has sides that are 20.9 millimeters by 11.1 millimeter by 11.9 millimeter. What is the density of this slab of lithium? In the typical units, grams per cubic centimeter. Okay, so we want to know what the density is. I am going to highlight that. That's our ultimate goal here. And to figure that out, we need the mass in grams. And we need the volume in units of cubic centimeter. If we find those two things, we are in business. We can certainly quickly punch numbers into our calculator and solve, okay? So when I'm faced with problems like this, I don't know if I'm just a little bit lazy or like to get some, build some confidence and build some momentum. So I try to usually look for the term that's easiest to come by, okay? And I look at mass here. We're talking about a lithium object that has this mass. It's 1.49 times 10 to the third milligrams. Now that is, of course, a mass. It's in milligram units. The only problem with it is that when we plug into our density equation, we want our mass to be in grams, not milligrams, which would be typical for density. And I said, okay, well that's not too bad because I know that I can use my dimensional analysis or my conversion factor approach to get rid of my undesirable units, which is milligrams, and convert into my desirable units, which is going to be grams. The milligrams are going to cancel out in the calculation, and all I need is the numbers to plug in here, which are, of course, again, physically equivalent. And I remember from my metric prefixes that there are 1,000 milligrams in 1 gram, so it looks like I'm going to have to divide by 10 to the third. And when I do so, I get 1.49 grams, okay? So the mass of this slab of lithium is 1.49 grams. I'm pretty happy that that was pretty easy and straightforward. I won't say easy, I'll say straightforward, right? Because I can plug that number now in right here into this equation for my density, and I'm halfway home, right? I got my mass. Now I just need my volume, so I'm building some momentum here towards getting the correct answer. That's what I always like to do. To give myself some confidence with what I'm doing, right? So now we got the harder one of the two, however. We got the mass, but we need the volume. So what do we know about this slab of lithium, okay? We're basically given the dimensions. We're told how big it is on edge, okay? So it's almost like, it's sort of a three-dimensional volume. These are the dimensions. Now, it could be kind of confusing, perhaps, to keep track of all that. If you're confused and you're kind of a visual learner, a visual person, you might say, which I find a lot of people actually are, so don't feel unusual if you're that way. I think it's kind of just a human thing, as it turns out. But what I encourage you to do is to draw yourself a picture of what is going on. Whenever you're confused, draw a picture and see if you can figure out what the problem's telling you. Figure out what's going on, okay? So that's what I did. I drew my slab of lithium here, okay? And I even labeled the edges, 20.9 millimeters, 11.1 millimeters, 11.9. Now what I'd like to do is ultimately come across the volume. And if you think back to like geometry days, right? The volume of a three-dimensional object, it's the height times the width times the depth. So that's going to be our approach, or our strategy for figuring out the volume of this slab of aluminum. The only potential issue is, ultimately we want our volume to be in cubic centimeters, not in cubic millimeters. So my first step, I could convert later, but I'm going to convert now. I think it's a little bit easier, a little more straightforward, okay? My first step is to convert into centimeter units and away from the millimeter units, okay? Now for every 1 centimeter, it's a bigger distance than a millimeter, there's a 1 to 10 conversion factor. So I basically have to divide all these numbers by 10. So instead of having 20, now I'm going to have 2.09. centimeters. Okay. Now in a likewise fashion, for this side, I'm going to have 1.19 centimeters. And for this side, 1.11 centimeters. I'm going to just divide them all by 10. Same kind of conversion, just millimeters to centimeters. Okay? With me on that? All right, hopefully so. Now, armed with these numbers, we can come back to our equation for computing volume, which was again the height times the width times the depth. We can plug in our actual values. Okay? It doesn't matter which one you call height, and which one you call width, and which one you call depth. Get the same answer either way, of course. So 2.09, we're going to multiply that by 1.19. We're going to multiply that by 1.11. All right, so we multiply those three numbers together. And if we do the math on that, I do believe we get 2.76 centimeter cubed. Okay, so circle that in so that we can keep track of everything. So what we just did is we successfully now computed the volume of this slab of lithium. So now we can go back to our density equation here, write 2.76 centimeters cubed into my equation. I've got my mass, I've got my volume, and now I can do my division. I'm running out of space over here, so I had to write the units of measure down below. But the result you end up getting is 0.54 grams per cubic centimeter. Okay? So this is another type of problem you could see in Chapter 1.